This is the November 2024 Edexcel GCSE paper 3, the second of the two calculator papers. Question number 1, frequency polynomial. So plot each point at the midpoint, connect up their frequencies, and you have yourself a frequency polygon like so. This is the only one where you plot at the midpoint of a class interval. For 2a, I'm writing it as an ordinary number, 340200, and then 8.026 times 10 to the minus 1. Then for the angle bisectors, take a pair of compasses, stick the pointy bit in B, then stick the pointy bit in the two intersections of the two lines and draw two more arcs and then join them up. I apologise at how poor that representation is. It's truly awful. Probabilities were summed to 1, so we'll get a 0.7 at the bottom there, and then 0.3, 0.7, 0.3, 0.7. Probability of not winning either game, well, 0.7 and 0.7, so 0.7 times 0.7, which is 0.49. For the pens and pencils, we divide 240 by 3 plus 5, so that's 30, that's one part. 3 parts is therefore 90, 5 parts is 150, that's the number of pens to the number of pencils. And then we've got to work out for each one how much they earned, and then how much they bought them for. They bought them for 1710. They made 2490, and then to find the percentage profit, find the difference between them, 2490 minus 1710, divide that by 1710, times it by 100, and that's 45.6% profit. Pretty healthy profit, if you ask me. Here's an option for finding the median of a stem and leaf. You can just cross off the first and the last, each time, and if you do that carefully, the one you're left with, or if you're left with 1, that will be your median. If you're left with 2, you find halfway between them. In this case, we're left with 57. So the median is 57. You can just work out what's going to be 13th and count them in. It's just a different way of doing it. Therefore, the median of A is higher than the median of B. For the range, it's just the distance between the first and the last, or the largest and the smallest. So 79 is the largest, 30 is the smallest. The difference between those two is 49. So the range of A is 49. Well, that's a larger number than 47. Therefore, the range of A is higher than the range of B. And there we go. Question 7, Jana, we've got lower bound 10.2, upper bound 10.3, that's your error interval. Tan of 62 will be the opposite, AB divided by the adjacent, 7.6, multiply both sides by 7.6, AB will be 7.6 times tan of 62, plug that in your calculator, you get 14.3, that's the length of AB. Question 9, 2 times 7 is 14, x to the power 3 times x to the power 2 is x to the power 5, and y to the power 5 times y is y to the power 6. 2 times minus 3 is minus 6, so b is m to the minus 6. For 10, reverse percentages, the old price times by 0.85, that represents a 15% reduction, is 46.75, so divide 46.75 by 0.85, and you get £55, which is the original price. question 11, theta 360ths of 2 pi r. Theta 360ths of 2 pi times the radius plus 2 lots of the radii will be equal to the perimeter of the shape 34.3. So subtracting the 2 times 4.7 from both sides and just rearranging the way I'm writing the first calculation, just to leave the theta on its own there, because then I can divide both sides by 2 pi times 4.7 over 360. Calculators will allow you to do that. Theta comes out as 304 degrees. Question 12, Rudy's investment, 45,000 times by 1.024 and then times by 1.018 squared comes out as 4775.38. Then for question B, I'm just going to find sort of the rate of depreciation first and then convert that into percentages. So I'll call that rate R rather than using X. Divide by 7,500, square root it, and we get R to be 0.74. 0.74 represents a 26% reduction. You're finding 74% of the original amount. So 26% reduction, so X is 26. For 13, we're dealing with two similar triangles, ABE and ACD. We know that B to E is 4.2, C to D is 6.3, and A to C is 10.8. So pairing up the sides, A to B and then A to C are paired up, so AB over AC, AB over 10.8 will be equal to 4.2 over 6.3. Times both sides by 10.8, we get A to B equals 4.2 over 6.3. I've written 4.4 there, that's a mistake. It doesn't count if I spot it though, so don't write in about that one. A to B equals 4.2 over 6.3 times 10.8, which is 7.2. We can subtract 7.2 from 10.8 to find the length BC. BC is the height of the trapezium, so half the sum of the parallel sides times the distance between them. Half of 4.2 plus 6.3 times by 3.6. The area comes out as 18.9 square centimetres. Question 14, x equals 0.4 and then 6.2 recurring. Multiply both sides by 10 to bring the decimal point, the recurring part up to the decimal point. Times by 100. Because we have two recurring decimals, subtract the smaller one from the larger one to cancel the recurring parts, divide by 990 and simplify to get 229 over 495, which is what the question wanted. For question 15, changing of subject, so multiply both sides by 5 minus 2p. I expand the right hand side out at the same time. Then I'm going to bring the p's onto the right hand side and the non-p's onto the left. The reason I've done that is to just keep everything positive. If you did it the other way and brought the p's onto the left, you can still get the correct answer, you just have lots of negatives in it. Then factorise a p out, so p lots of 4 plus 2t on the right. Divide both sides by 4 plus 2t, we get p equals 5t plus 6 over 4 plus 2t. Question 16, we know b is at 2, negative 4. We know e is at 12, negative 6.5. So first thing I'm going to work out is the gradient of the line going through the origin and B. So that the gradient of the line OB is going to be negative 2. We know that O to D is going to be perpendicular to that, so negative reciprocal of negative 2 is a half, so O to D has a gradient of a half. We know it passes through the origin, so the equation of the line passing through O to D is y equals a half. Now, gradient of D to E, where D to E is parallel to O to B, so the gradient of D to E is -2. We know it passes through the point E, so I can substitute the y coordinate negative 6.5 in, the x coordinate 12 in, and then solve the equation to find the value of C. And C comes out to 17.5. Therefore, the equation of the line passing through D and E is y equals -2x plus 17.5. To find the coordinates of D, we can just solve simultaneously the equations of the two lines we've constructed. Y equals a half x and y equals -2x plus 17.5. Any number of ways from this point onwards that lead to an answer of 3.5 is correct. I've substituted y for a half x, brought the x's onto the left hand side, times by 2 divided by 5, x equals 7, y equals 3.5, and those are the coordinates of D. Alright, question 17 is a cosine rule. I'm going to jump straight in with the version of the cosine rule that finds the angle. If you know this one off by heart, it makes life much easier. We'll say that cos of the angle is b squared plus c squared minus a squared over 2bc. And then if I do inverse cos of that straight away, it will give me the angle. Now you could have picked any of these angles and that would have been fine. So if you picked a different one to me, don't worry about that. You'll end up with the same answer if you've done it correctly. The angle comes out as 103.965 for mine. And then using a half AB sine C, make sure you pick the two lengths either side of the angle for that one. Plug in the unrounded angle and you get 55.965, which rounds to 56.0 is the correct answer for 17, 56.0. For 18, well, 40 out of the total number of frogs is going to be equal to 11 out of 55, assuming the proportions are the same. So you can divide both sides by 11 over 55 times by n. N will be 200 there. And we're assuming that the number of frogs on the 2 days has not changed. So I will write that no frogs have hopped off. Question 19 with the cone, let's draw a height and a radius. We know that the height, we want to find the height, so let's call the height h. The radius is 3/4 of that, so let's call the radius 3/4 of h. We need the slant height here, so the angle between the height and the radius is 90 degrees, so I can use Pythagoras on those two, so the square root of h squared plus 3/4 of h squared. That will give us a slant height. 3/4 of h squared is 9/16 h squared. Add h squared to that, you'll get 25/16 of h squared, which simplifies down quite nicely to 5 over 4 lots of h. That's my slant height. That's all the information we need now. So using pi RL for the curved surface area, pi times the radius 3/4 h times the slant height 5 over 4h. Add the circle on the bottom, pi r squared, pi times 3/4 h all squared equals 54 pi. That's what it tells us in the question for the surface area. All that remains is for us to now solve this equation to find h. So 3/4 times 5 over 4 is 15/16. Squaring 3 over 4 is 9/16. And grouping those all together, divide both sides by pi. 3 over 2h squared equals 54. Divide both sides by 1.5. H squared equals 36. Our height is 6. Question 20, we have simultaneous equations. There's a little clue here. It says give answers to correct to 3 sig figs, so we know this is not going to be a pretty one. Rearranging the linear equation to make y the subject. It's much easier to make y the subject here than x, because otherwise you'd be dealing with a fraction. We get y minus 7 minus 2x. Substitute that into the first equation. Replace the y with 7 minus 2x. Expand it all out. 49 minus 28x plus 4x squared is equal to 3x squared plus 4. Bring everything onto the left-hand side. X squared minus 28x plus 45 equals 0. Then I'm going to jump in the formula here. Minus b plus or minus the square root of b squared minus 4ac all over 2a. A is 1, B is negative 28, and C is 45. And that gives us two values when we plug that into the calculator. The first value is 26.3, rounded to 3 sig figs. And the second value is 1.71 when rounded to 3 sig figs. I'm going to use the rearranged linear equation from earlier, y equals 7 minus 2x. Plug my x value in. For the first one we get a y value of negative 45.6, and for the other one we get a y value of 3.57, and those solutions come in pairs, so I'm going to pair them up. Okay, y equals minus f of x, that's just reflecting it in the x-axis. So my x-axis is a mirror line, picking the important points where the graph changes and plotting those. Wherever it crosses the x-axis, it's going to cross at the same point on the reflection. And there we go, a nicely reflected shape. So the coordinates of P for this one are 270, negative 1. That's just true for sine x. And then our transformation moves it 180 degrees to the left and then 4 places up. So 270 minus 180 is 90. Minus 1 plus 4 is 3. We get 93. For the velocity time graph, we're splitting this up into 3 strips. So I'm going to draw the lines at 10, 20 and 30 and then work out each of the values of each one of those points. So we're going to get 92, 76 and 54. Now we're adding together a triangle and 2 trapeziums. So the first triangle, half times 10 times 54. The first trapezium, a half of 54 plus 76 times by the difference between them, 10. And then the last one, a half times 76 plus 92 times 10. So the triangle is 270. The first trapezium is 650, and the second is going to be 840. So those sum to 1,760. Question 23, completing the square. Half of negative 6p is negative 3p. So x minus 3p all squared. Subtract 3p squared, which is 9p squared. Subtract 7. So that tells us that the minimum point is going to be at 3p for the x-coordinate and minus 9p squared minus 7 for the y-coordinate. Crosses the y-axis at negative 7. We can read that off the first equation, that's the constant. And we are done. Well done if you got that one. All right, bye.